Hello, dear listeners, and welcome to Sleepy Science Teller. I'm so glad you're here tonight. It's time to settle in, to take a deep breath, and to let your mind drift softly into the calm wonder of science and imagination. Tonight, we'll be exploring something both mysterious and beautiful, a question that humankind has whispered about for centuries. What if there are other versions of reality quietly unfolding beside our own? This is the science of parallel universes. For as long as we've looked at the stars, we've wondered, are we alone in the cosmos? But now, science asks something even deeper. Are we alone in reality itself? Could there be countless other worlds existing in layers beside our own, each just slightly different, each with its own sky, its own stars, and perhaps its own you? Before we begin, I'd love to know where in the world you are listening from tonight. Would you gently type your city and the time where you are in the comments below? It's always so peaceful to imagine all of us together, sharing the same quiet curiosity from every corner of the earth. And if you enjoy drifting off to these soft explorations of science and wonder, please take a moment to like this video and subscribe. Your support helps this calm little corner of the internet stay warm, gentle, and full of discovery. Close your eyes for a moment and imagine yourself standing beneath a quiet night sky. The air is still, and the stars seem to shimmer like silver dust across a dark ocean of time. You look up, and for a brief instant, a thought passes through your mind. What if this isn't the only sky? What if, somewhere beyond what our eyes can see, there are other skies, other stars, and perhaps other versions of you looking back at their own heavens and wondering the very same thing? This gentle question is the beginning of one of the most fascinating mysteries in all of science, the mystery of parallel universes. For centuries, we believed that our universe, this one vast, expanding cosmos of galaxies, stars, and planets, was everything. It held all there was and all there ever could be. But now, science whispers something far more profound, something quietly breathtaking. Perhaps our universe is only one note in an infinite symphony. Perhaps countless other realities exist, layered beside ours, each vibrating at its own frequency, each following its own laws of nature, each holding its own story. When you think about it, the very idea of a universe, uni, meaning one, might be misleading, because if the multiverse exists, then reality is not one thing, but many things woven together in invisible harmony. Scientists call this grand idea the multiverse theory, but before it had a name, it lived in myths, in dreams, and in the quiet spaces of imagination. Ancient philosophers once imagined that existence might be endless, not just in time, but in kind. Some believed that every possibility that could exist does exist somewhere in another unseen realm. And though they had no telescopes, no quantum equations, their intuition touched something deep, a sense that reality might be much more mysterious than the world we see before us. As centuries passed, science began to replace wonder with reason, but even reason, when followed far enough, leads back to wonder. Astronomers mapped the cosmos and realized it was expanding. Then physicists explored the tiniest particles of matter and found uncertainty at the heart of everything. And from those discoveries, a question reawakened. What if our universe is just one of many, each branching, each existing beyond the veil of perception? The idea seems strange, almost dreamlike, and yet it feels right, doesn't it? Because somewhere deep inside, we've always sensed that existence might be greater than what meets the eye. When you stand at the edge of an ocean and look out into the infinite horizon, you feel it, that quiet awe, that sense of endless possibility. And that feeling is what scientists feel too when they think about the mystery of parallel universes. The beauty of science is that it takes our wildest dreams and asks gently, could this be real? When scientists first began to study the structure of the cosmos, they discovered that our universe has limits, boundaries defined by light and time. The farthest galaxies we can see are about 46 billion light years away. Beyond that lies darkness, not because nothing exists there, but because light from those places hasn't yet reached us. This region, the observable universe, is all we can directly detect. But what if the cosmos continues far beyond what light can travel? What if it never ends? If space truly stretches to infinity, then statistically, the arrangement of matter, the stars, planets, atoms, must eventually repeat. Somewhere impossibly far away, the same sequence of particles that make you might appear again. Another Earth, another galaxy, another you, thinking, breathing, dreaming. This isn't fantasy. It's mathematics. In an infinite universe, every configuration must eventually recur. It's a quiet and humbling realization, but the mystery deepens. Even if our own cosmos is infinite, there may be other universes completely separate, with their own beginnings, their own rules of physics, perhaps even their own dimensions. Some scientists call this the level 1 multiverse, the simplest form where different regions of infinite space never interact, but exist side by side. Others imagine a level 2 multiverse, born from the chaotic expansion of the Big Bang, a cosmic foam of countless bubble universes, each floating in a sea of higher dimensional space. And deeper still, are theories so strange, so abstract, that they begin to sound like poetry. In these ideas, universes exist not in space, but in mathematics itself, as pure possibilities, each governed by its own internal logic. Our universe, in this view, is just one mathematical structure that happens to contain conscious life. It's an unsettling thought, but also a deeply peaceful one, because if all realities exist, then every joy, every loss, every dream has a place in the grand tapestry of being. And though we can only perceive one reality, science reminds us that the unseen may be far greater than the seen. Let's return for a moment to that image of you beneath the stars. The night sky glows softly, the air hums with quiet stillness, and your mind drifts through the questions of existence. Somewhere in that endless expanse, a star is being born, and somewhere else, a star is dying. The universe is full of beginnings and endings, woven together in one continuous story. But if parallel universes are real, then every possible story is unfolding simultaneously. Perhaps in another universe, you made a different choice years ago, took a different path, and found yourself living a different life. In another, the Earth might orbit two suns, and the sky might shimmer in shades we've never seen. And somewhere even farther still, the laws of gravity, light, and time might dance to rhythms beyond our imagination. This is what makes the mystery of parallel universes so deeply moving. It reminds us that existence itself is not confined. We often think of our lives as single lines, beginning and ending within one world. But what if life, and reality itself, is more like a vast ocean? Each wave, each ripple, is a universe, rising, changing, and fading into the next. And just as waves belong to the same sea, perhaps every universe belongs to a single silent source, a deeper field of creation beyond all form. Science, for all its precision, cannot yet explain what this source is, but the search for parallel universes draws us closer to it, because to study existence is to look into a mirror, one that reflects not just the world outside, but the wonder within us. Every time we gaze at the stars, we're also gazing at possibilities, the unseen dimensions of reality, and the infinite potential of our own minds. Perhaps that's why the idea of parallel universes feels so strangely comforting. It whispers that reality is vast, that every choice matters, and that somewhere in the endless expanse, every version of life, every joy, every possibility is cherished and alive. So as you breathe softly and let your thoughts drift through the quiet spaces of imagination, know this: you are part of something endless, something mysterious and beautiful. The mystery of parallel universes isn't just about the cosmos beyond. It's also about the universe within. Imagine for a moment the entire universe resting inside a single point, a point smaller than a grain of sand, and yet somehow holding every atom, every star, every dream that would ever exist. This is how our own universe began, with the Big Bang, an explosion not in space, but of space itself. From that first instant, space and time stretched outward, expanding like the surface of a balloon. Galaxies formed, stars ignited, and eventually, tiny worlds like ours began to bloom. For a long time, scientists thought this event created everything, one universe, born from one beginning. But as our understanding deepened, a quiet question began to rise, like a distant echo in the fabric of space. What if the Big Bang wasn't the only one? What if countless other bangs happened beyond our view, each giving birth to a separate universe, each with its own space, its own time, and its own story? This is the seed of the multiverse, a breathtaking concept, that reality might be plural, not singular. It began as a whisper among physicists, a mathematical curiosity, a strange possibility that emerged from the very equations used to describe our own universe. You see, when scientists study the early universe, they notice something intriguing. Certain models of cosmic inflation suggest that expansion might never completely stop. In some regions, it slows down, forming universes like ours, but in others, it keeps going endlessly, creating new universes over and over again. Each universe becomes a bubble drifting in a sea of higher dimensional space, a multiverse. Our own universe, then, might just be one bubble, floating gently among an infinite foam of others. Some bubbles might pop quickly, others might grow immense, and some might form laws of physics. So different that life, as we know it, could never exist there. And yet, somewhere perhaps, others might hold skies that glow with the same kind of light we see tonight. The multiverse is not just a scientific theory. It's a bridge between imagination and reality. It challenges the idea of everything and replaces it with something even more profound. Infinity. When you think about it, it makes you feel both small and limitless, like standing at the edge of an ocean that stretches forever, where each wave is its own world. Now, let's wander deeper into the science of the multiverse. Softly, gently, without rushing, like exploring a dream. To understand the multiverse, we must start with the idea of inflation. After the Big Bang, our universe didn't expand slowly. It expanded at unimaginable speed, doubling in size over and over in fractions of a second. This process is called cosmic inflation. It smoothed out the universe, explained the even spread of matter, and gave rise to the galaxies we see today. But here's the strange part. Inflation might not be a one-time event. According to some models, it could be eternal. In this eternal inflation, the universe keeps expanding in different regions, creating countless pocket universes. Each one emerges from its own local Big Bang, each forming with slightly different physical laws. One might have stronger gravity. Another might have no stars. In one, atoms might never form, while in another, life might bloom in forms we cannot imagine. This kind of multiverse is sometimes called the inflationary multiverse. It's not science fiction. It's a serious idea supported by mathematical logic. But there are other kinds too. Some theories suggest that quantum mechanics itself creates a kind of multiverse. Every time a quantum event occurs, every time a particle chooses a path, reality may branch, creating parallel outcomes. We'll explore that in our next keynote. But for now, know that these ideas interconnect beautifully. The cosmic and the quantum, dancing together in infinite possibility. And there's yet another kind of multiverse, hidden in the geometry of existence itself. In string theory, our universe might be just one membrane, or brain, floating in a higher dimensional space. Other brains could exist beside ours, each a self-contained universe, with its own dimensions and particles. Sometimes, these brains might even collide, releasing bursts of energy that look, to us, like a Big Bang. So perhaps our own creation was not the beginning of everything, but simply the moment two higher worlds brushed gently together. These ideas sound like poetry, and in a way they are, because science at its heart is a form of cosmic poetry. It takes the mysteries of existence and translates them into patterns and equations that speak of wonder. And what's most humbling is that all these theories, inflationary, quantum, string-based, fit together like pieces of a grander puzzle. Each suggests that reality is larger, deeper, and more diverse than we've ever imagined. Now, let's pause, take a slow, calm breath, and imagine the multiverse itself. Not just the stars or galaxies we know, but countless universes stretching into infinity, like lanterns glowing across a boundless sea. Each universe carries its own story, its own birth, its own destiny. Some might live for only a heartbeat. Others might last trillions of years. Some might sparkle with unimaginable beauty, while others remain dark, quiet, empty, and yet they all exist together, woven into the grand pattern of creation. In this vastness, our own universe is but one melody in a cosmic symphony. Our stars, our lives, our entire history may be just a brief note in a song that never ends. But that's what makes it so precious, because in this infinity, we are here, experiencing it, wondering about it, giving it meaning. If the multiverse exists, then it holds endless versions of reality. But this one, the one we're in right now, is uniquely yours. Every moment you live, every thought you think, every breath you take, is part of the rare and delicate balance that defines this universe. You are living inside one of countless possible worlds, and yet, to you, this one feels like home. That's the quiet beauty of the multiverse. It doesn't make us smaller. It makes us part of something boundless. It reminds us that the universe isn't just a place we live in. It's a living mystery, an infinite web of creation that includes everything we can imagine and everything we cannot. As scientists continue to search for proof through cosmic background radiation, through quantum models, and through deep mathematics, they're not just looking for other universes. They're looking for understanding. And perhaps that's what connects us most to this grand cosmic idea. Because even though the multiverse may forever remain beyond our reach, the curiosity that leads us toward it lives within us. It's the same spark that makes a child look at the stars and wonder what's beyond them. It's the same light that moves through every era of discovery, softly guiding us toward the unknown. And maybe, just maybe, the multiverse isn't only a theory about outer space, but also a reflection of our inner one. Because inside every human mind, there are endless possibilities, countless thoughts, countless dreams, each a tiny universe of its own. When you close your eyes tonight and drift between waking and sleep, you too create a multiverse, a realm of imagination where all things are possible, where reality itself becomes soft and infinite. And perhaps that is the quiet truth behind the multiverse concept, that reality, both outside and within, is far greater than we can ever truly know. Imagine for a moment that you're floating in a space far smaller than atoms, a place where the rules of the everyday world begin to dissolve, where matter blurs into waves of possibility, and certainty fades into a gentle, shimmering haze. This is the quantum world. Here, everything behaves in ways that seem impossible. An electron can spin in two directions at once. A photon can travel through two paths simultaneously, and a particle can exist in multiple locations. Until we look at it, this strange phenomenon is known as quantum superposition. It's one of the most mysterious and yet most fundamental principles of quantum physics. To understand it, let's imagine something simple. Picture a coin spinning in the air. When it's spinning, you can't quite say whether it's heads or tails. It's both, in a sense, not one, not the other, but both possibilities held together in motion. Now imagine that coin isn't made of metal, but of pure energy, existing at a quantum level. That's what happens to particles. They don't simply wait to be one thing or another. They exist as a combination of all possible states, a beautiful blur of probabilities. This means that, before observation, a particle isn't here or there. It's here and there, everywhere, and nowhere, all at once. It sounds impossible, and yet this is one of the most well-tested truths in physics. The double-slit experiment, first performed in the early 1800s with light and later with electrons, proved it elegantly. When scientists fire particles as screen through two slits, they expected to see two bands, one for each slit, but instead they saw a wave-like interference pattern, as if each particle had gone through both slits simultaneously, interfering with itself. And when they placed detectors to see which slit the particle passed through, the interference disappeared. The pattern changed. It was as if the particle knew it was being watched and chose one path. This is the mystery of observation. At the quantum level, reality seems to remain uncertain until consciousness or measurement collapses it into a single outcome. It's as though nature waits for awareness before making up its mind. This is the strange, shimmering beauty of quantum superposition, a place where all possibilities coexist, waiting to unfold. And if you listen closely, it almost sounds like the universe is dreaming itself into being. Now, you might wonder, if quantum superposition happens at such a tiny scale, does it matter to us? Does this strange dance of uncertainty actually shape the world we see and feel? The answer is yes, profoundly so. Everything around you, every atom, every breath, every heartbeat arises from this quantum foundation. Every solid object you've ever touched is made from particles that once existed in overlapping possibilities. The table, the moon, the oceans, your very body, they are all built from quantum waves that have gently settled into being. But what truly fascinates scientists is the question of when and how that settling happens. At what point does a particle in superposition decide on a definite state? Is it when it interacts with another particle? When it meets a measuring device? Or only when it is observed by a conscious mind? This question lies at the heart of quantum philosophy. Some scientists, like Niels Bohr and Werner Heisenberg, believe that measurement itself, the act of interaction, collapses the wave of possibilities. Others, like Eugene Wigner, propose that consciousness plays a role, that reality doesn't become real until it is experienced. And still others believe that nothing ever truly collapses at all, that all possibilities continue to exist, each one unfolding in its own universe. We'll explore that soon in the many worlds interpretation. But for now, let's stay in this delicate space between knowing and mystery. Quantum superposition reminds us that even the smallest parts of nature are profoundly creative. They don't rush to choose, don't hurry to decide. They linger, they explore all outcomes. They wait in stillness until a moment of connection brings one possibility into focus. It's a lesson, perhaps, woven gently into the structure of existence. That uncertainty isn't chaos, it's potential. The universe, at its deepest level, doesn't move in straight lines. It swirls, it drifts, it hums softly with endless options. And in that subtle hum, all creation begins. Let's drift a little deeper, beyond science, into reflection. Quantum superposition isn't just a physical idea. It's also a mirror, showing us how existence itself might truly work. In our daily lives, we often see things as fixed, this or that, yes or no, one path or the other. But the quantum world tells us that reality is far more fluid. At every moment, countless possibilities surround us, each waiting to unfold. Just like particles in superposition, Our choices ripple through space and time, branching into different versions of what could be. When you stand at a crossroads, you might think you're choosing one future, but perhaps, in some quiet way, every possible future continues, each in its own faintly shimmering world. This is where science and wonder begin to merge, because when we speak of quantum superposition, we're not just describing particles, we're describing potential itself, the raw material of existence. Every idea you've ever had, every dream, every what if is a kind of superposition hovering between reality and imagination. And when you act, you collapse that potential into something tangible, a single path, a single experience, the same principle that allows particles to explore many states, also seems to guide us through our own unfolding possibilities. In a way, the quantum world is whispering a gentle truth that the universe is not fixed, but ever becoming. Even scientists, when they observe particles behaving as waves, describe them as probability clouds, soft mist-like patterns that exist not as things, but as chances. It's as though reality itself is painted in brushstrokes of probability, gathering form only when touched by observation, by awareness. And that brings us to one of the most haunting questions of all. What is observation? What is the role of consciousness? In this quantum story, does the universe exist because we look at it, or do we look at it because it exists? No one truly knows, but perhaps that's the beauty of it, because uncertainty isn't something to fear. It's the quiet heartbeat of discovery. It's what makes science alive, what makes art meaningful, and what makes every moment so precious. Quantum superposition teaches us that the universe is not built from certainty, but from potential, from shimmering possibilities that dance together in delicate harmony. And maybe that's what life itself really is. Each thought you have, each action you take, each dream you follow is one possibility out of many. And even though we can only live in one version at a time, the others, the maybes, the could-be's, the almosts, remain part of the great unseen web of creation. So as you rest tonight, imagine the quantum world as a lullaby, a soft vibration of infinite chances, a whisper that says, nothing is ever truly impossible, because deep down, the universe itself is still deciding what to be. Close your eyes for a moment and imagine standing at a fork in a road. To the left, a quiet path lined with trees. To the right, a winding trail that disappears into mist. You hesitate, wondering which to take. And then, in one universe, you choose the left, but in another, you choose the right. Both decisions are real. Both paths are walked. Both versions of you continue on, each unaware of the other. This is the essence of the many worlds interpretation. It began in 1957 with a young physicist named Hugh Everett III. He was studying the strange riddle of quantum mechanics, the same riddle that troubled Einstein, Bohr, and countless others. Quantum theory worked beautifully in practice, yet its meaning was endlessly debated. In particular, scientists were puzzled by collapse, the idea that when you observe a quantum system, its many possible states collapse into just one. Everett wondered, what if the wave function never collapses? What if every possible outcome actually happens, but in different parallel universes? in his interpretation. Reality doesn't make choices, it simply branches. Each time a quantum event occurs, the universe divides, creating a new version of itself for every possible outcome. When a photon passes through a double slit, it doesn't pick one path, it takes both, and each path creates a new world. When you flip a coin, in one universe it lands heads, in another, tails. When you make a decision to move, to stay, to speak, to remain silent, each possibility unfolds, each becoming its own universe, complete and real. The many worlds interpretation doesn't destroy the idea of quantum superposition. It explains it. In Everett's view, particles don't exist in a fuzzy mix of states. Instead, each possible state exists in its own separate branch of reality. We don't see these other worlds because they exist beyond our perception, parallel, untouchable, like echoes of possibility. To most physicists of the time, Everett's idea was shocking, too bold, too strange, too infinite. But as decades passed, his theory quietly gathered strength because it solved one of the deepest problems in physics, the problem of observation. In the many worlds view, there's no need for the universe to choose. Every outcome exists. Every possibility is realized. Nothing collapses. Everything continues. It's a breathtaking idea, and a humbling one, because it means that right now, as you listen, there might be countless other versions of you, each living out a slightly different story. In one, you chose a different path. In another, you said the words you didn't say. In another still, you followed a dream you set aside. Each decision, each chance, each breath creates a new ripple in the fabric of reality. It's as though the universe is endlessly blossoming, splitting into infinite petals of existence. Each one is real as the next, and all of them together form the cosmic garden we call the multiverse. Let's imagine this more deeply. Think of the universe as an enormous tree. Its trunk is the birth of time, the Big Bang. From that trunk, branches emerge, each one representing a possible history, a different way the cosmos could unfold. Some branches grow close together, almost parallel, their worlds nearly identical. Others twist far apart, so different that their physical laws themselves might not match our own. Now imagine that this tree doesn't stop growing. At every quantum event, every atomic vibration, every photon scattering, every thought, every choice, new branches appear. Each branch carries its own version of events, its own continuation of time. This is the quantum multiverse, as envisioned by Everett. To him, reality isn't a single film strip, playing out one story. It's an infinite collection of films, all running at once, each with its own storyline, its own outcomes. But here's what makes it even more fascinating. We as observers are part of that process. When we measure a quantum system, we too become entangled in it. If a particle can be in two states, then after observation, there are two versions of us, each perceiving one outcome. You don't watch the universe split from outside it. You split with it. This means that every observation, every experience, creates a branching version of you. You are not a single traveler, but an entire constellation of selves, each walking a unique line through the forest of time. It's difficult to imagine because we experience life as continuous, unbroken, one decision at a time. But In the quantum view, every possibility continues, each with its own momentum, its own unfolding. Physicists call this process decoherence, when quantum systems interact with their environment and diverge into distinct, non-interfering branches. To us, it feels like randomness, but to the universe, it's simply expansion, a natural blooming of all outcomes. And though we can't cross between these branches, they may subtly influence one another through patterns, resonances, or the mysterious quantum connections we're only beginning to understand. The many worlds interpretation invites us to see reality not as a single line, but as a vast, shimmering web, each thread glowing faintly with its own version of truth. It reminds us that what we call the world is just one story among endless others. And perhaps in another universe, you are hearing these same words at a slightly different moment under a slightly different sky. Now, let's drift into reflection. If every possible outcome exists, what does that mean for choice? For fate? For the meaning of life itself? Some find comfort in the many worlds idea, because it means nothing is ever truly lost. Every dream you didn't chase, every word you didn't speak, every road you didn't take, somewhere in another branch, you did. Another version of you is living that life right now, perhaps wondering what became of the you that stayed here. But others find it unsettling. If every possible version exists, does that make any single choice matter? If all paths are real, how we find purpose in the one we walk, and yet perhaps meaning lies not in what happens, but in how we experience it. Even if the universe is infinite, each version of you feels, learns, and grows uniquely. Your consciousness, your awareness in this moment, is what makes this branch real to you. You are, in a sense, the universe choosing to look through one lens, one story, one lifetime. And while other versions may exist, you are the one experiencing this now. It's like standing before 1,000 mirrors, each showing a different reflection, but only one reflection looks back with your eyes. The many worlds theory, beyond its science, carries a quiet philosophy. That existence is not limited by boundaries, but by awareness. You are not a separate being, drifting through space. You are space itself, exploring its infinite expressions. Every decision you make is a creative act of the universe, spawning new realms, new patterns of possibility. And though you may never meet your other selves, you are all part of the same great tapestry, woven by quantum threads, bound by mystery. So when you look at the stars tonight, remember, you're not just gazing into space. You're gazing into infinity, into all the worlds that might have been, and all the ones that still could be. Somewhere out there, another version of you is looking back, wondering the same, and perhaps, in some quiet, quantum way, your thoughts and theirs still touch, because in the end, the many worlds interpretation isn't only about physics. It's about wonder, the vast, infinite imagination of existence itself. Imagine a universe smaller than an atom, filled with light that has not yet learned to shine. In that timeless silence, before galaxies, before stars, before even atoms existed, something extraordinary stirred, a fraction of a second after the Big Bang. In a time so small it defies comprehension, the universe expanded, not slowly as we might imagine, but explosively, like a cosmic breath that filled the void. This was cosmic inflation, a theory proposed in the early 1980s by physicist Alan Guth. He sought to answer a puzzle: why the universe looks the same everywhere, no matter which direction we gaze. From the faint glow of the cosmic microwave background radiation to the even spread of galaxies, the universe appears astonishingly uniform. But how could regions so far apart, light years beyond one another, be so similar when light itself couldn't have traveled between them in time to share information? Inflation answered that riddle. Before expansion slowed to its current pace, the entire observable universe was once a tiny connected region, a microscopic speck. Then, in a breathtaking instant, it grew exponentially, doubling again and again. In less than a trillionth of a second, this rapid expansion smoothed out all irregularities, stretched quantum fluctuations into cosmic patterns, and gave birth to the seeds of stars, galaxies, and worlds. The uniformity we see today, the soft, even temperature of the cosmos, is a lingering echo of that inflationary moment. But here's where the mystery deepens. Inflation might not have ended everywhere at the same time. In some regions, it could have stopped, allowing matter, energy, and time to unfold into a universe like ours. But in other regions, it might have continued forever. This idea, called eternal inflation, suggests that our universe is just one bubble in an infinite cosmic foam. Each bubble expands. Each becomes a universe, each with its own laws of physics, its own stars, its own possibilities. We live inside one of those bubbles, a cosmic sphere suspended in the endless sea of the multiverse. Between these bubbles might lie vast voids of space-time, stretching beyond all reach or observation, and somewhere far beyond the edge of what we can see, another bubble may be forming right now, its own galaxies flickering to life. In their first light, it's a humbling thought that creation may never truly stop, that even as we dream beneath our own stars, new universes are being born in the quiet fabric of reality. Let's drift deeper into this idea. Imagine the universe not as a single balloon expanding, but as an endless foam of bubbles, each one vast, each one a universe in itself. This vision comes from the idea of eternal inflation, where the inflationary process doesn't stop all at once. Instead, it slows in pockets, forming bubbles of space-time that cool and stabilize, while inflation continues endlessly elsewhere. Every bubble becomes its own universe, sealed off by the expanding space between them. And because these bubbles can form under slightly different conditions, their internal physics may vary. Some may contain different kinds of matter, different particles, even different physical laws. In one, gravity might be stronger. In another, atoms may never form. In yet another, stars will burn blue and eternal, while in others, light might never exist at all. We can't see beyond our own cosmic bubble, because the expansion between universes is faster than the speed of light. Even if another universe lies just beyond the edge of our own, its light could never reach us. To us, the night sky would always appear silent, infinite, and solitary. And yet, the theory suggests that just beyond that silence, the multiverse continues, bubbling endlessly like a great ocean of universes, being born and reborn. Some cosmologists have likened it to boiling water, each bubble of boiling water, is like a separate universe, forming and expanding within the vast field of inflation. But these bubbles are far more than metaphors. They are mathematical predictions, emerging naturally from inflationary theory. And some researchers even suggest that our universe might bear faint scars of neighboring bubbles, tiny imprints in the cosmic background radiation, frozen whispers of where two universes might have once brushed together. Imagine that entire worlds colliding gently in the early fabric of creation, leaving only the faintest echo, like ripples meeting on the surface of a pond, though we may never see them. These neighboring universes may have their own versions of physics, their own constants, their own patterns of life and thought. It's a vision that stretches imagination beyond comfort, a reality so vast that our entire cosmos is but one droplet in a limitless sea. And yet, even this vastness feels strangely intimate because if inflation truly never ends, then creation itself is an eternal act. Somewhere always new space is blossoming, new time beginning, new light unfolding, an infinite breath rising and falling within the lungs of the cosmos. Let's pause for a moment and breathe in the wonder of it all. The inflationary universe, the bubble multiverse, the infinite ocean of creation. These are not just abstract theories. They are the modern echoes of something deeply human, our ancient need to understand where everything came from and whether ever truly ends. When we gaze into the night sky, we see only a small corner of our own bubble. The light from distant galaxies takes billions of years to reach us, and beyond that horizon, the universe stretches further still. But if eternal inflation is true, that horizon is only the edge of one bubble among countless others. We are travelers not through one universe, but through a cosmos woven from infinite threads. In one universe, perhaps Earth never formed. In another, the stars burn red instead of gold. And in yet another, a civilization like ours looks up and wonders the same thing. Are we alone? Perhaps the answer is both yes and no. We are alone within our bubble, but together within existence itself. For every bubble, every cosmos, every version of space-time is part of one greater whole, the infinite, breathing multiverse. In that grand design, nothing is ever lost. Every atom, every vibration, every spark of consciousness is part of the eternal expansion, a dance of universes, spinning quietly in the dark. And if you listen carefully, beneath the hum of existence, you might feel it, the slow, steady pulse of the cosmos itself, a pulse that began in that first instant of inflation and continues still, forever expanding, forever creating. Perhaps in another universe, you are hearing these same words at slightly different pace, the same thoughts spoken under another sky. Perhaps our bubbles drift near each other, touching at their edges, sharing a moment of gentle recognition, and then they drift apart again, carrying their stars, their stories, and their listeners, each dreaming their own version of infinity. So when you gaze upward tonight, let the thought comfort you that this universe, our universe, is not the only one. It is part of something far greater, a quiet, eternal creation that never truly ends. And somewhere beyond the edges of light. New universes are still being born, softly expanding, silently glowing in the vastness of forever. Close your eyes for a moment and imagine that everything, you, me, the stars, the galaxies, every atom and particle, is part of a cosmic symphony, not a metaphorical one, but a literal physical music played upon the tiniest strings of the universe. That's the heart of string theory. For much of the 20th century, scientists believed that everything in the universe was made of point-like particles, tiny dots of matter and energy with no size, no shape, just pure presence. Electrons, quarks, photons. These were the building blocks of reality. But as physicists peered deeper into the subatomic world, they found themselves confronted with questions that even the best theories could not answer. Why do the fundamental forces, gravity, electromagnetism, and the nuclear forces, seem so different, yet appear to spring from one common source? Why do particles come in families, with properties that appear finely tuned for the existence of stars, planets, and life? And why, despite all its success, does quantum mechanics refuse to merge smoothly with Einstein's general relativity, the beautiful theory of space and time? It was in the search for unity that string theory began to sing. In the late 1960s and early 1970s, physicists discovered that if particles were not points, but tiny one-dimensional strings, infinitesimal filaments of energy, then many of the mathematical contradictions of quantum gravity simply vanished. Each particle we observe in this view is not a separate entity, but a vibration pattern of the same fundamental string, just as the strings of a violin can produce many notes. Depending on how they vibrate, the cosmic strings vibrate at different frequencies, creating the illusion of distinct particles. An electron, a photon, a quark, all might simply be different notes on the same universal instrument. It's an elegant vision, the idea that the universe is built not from bricks, but from music. And yet, this music is not played in ordinary space. For the equations of string theory to work, they require extra dimensions, hidden layers of reality, beyond the three we can see, and the one we call time. Instead of a universe with 4 dimensions, string theory whispers of 10, or even 11, dimensions that are tightly curled, so small that they remain invisible to us, like intricate threads woven into the fabric of existence. If you could shrink yourself down to a billionth of a billionth of an atom, you might see them, tiny loops of space, folded in patterns, too delicate for the human eye. These hidden dimensions are what allow the strings to vibrate in countless ways, each vibration giving rise to a different force or particle. Gravity, light, the strong and weak nuclear forces, all may be echoes of the same song, played across unseen dimensions. It's a vision so strange, so mathematically beautiful, that many scientists find themselves both awed and humbled. For in string theory, the universe is not a chaotic accident. It is harmony, a single melody, resonating across infinity. Let's drift a little closer and imagine these hidden dimensions. To understand them, think of a simple garden hose. From far away, it looks like a one-dimensional line, just a length stretching forward. But if you move closer, you'll see that the hose actually has a second dimension a circular one wrapped tightly around it, to an ant crawling along the surface. Both dimensions are real. It can move forward or around. In the same way, the extra dimensions of string theory are thought to be curled up, tiny and compact, beyond our perception. At every point in our three-dimensional space, there could be 6 or 7 more dimensions, folded into intricate shapes, known as Calabi manifolds. These shapes are not random. Their geometry determines how the strings can vibrate, and therefore what kind of particles and physical laws exist in that universe. Change the shape of those dimensions, and the symphony changes, producing a different universe with different laws of physics. This leads to a breathtaking idea that the multiverse may arise naturally from string theory itself, if different regions of space have slightly different shapes for their hidden dimensions. Then each region, each bubble, would have its own physics, its own constants, its own version of reality. One universe might have gravity that's too strong for galaxies to form. Another might never allow atoms to exist. And yet another, like ours, might find itself balanced just right to give rise to stars, planets, and life. It's as if creation were a grand instrument that can play infinite variations of the same song. Each variation is a universe, a different verse in the cosmic melody. And though we can only hear our own verse, the music may be all around us, echoing softly through unseen dimensions. Some physicists even suggest that what we perceive as matter and energy are just vibrations, confined to a three-dimensional brain, a kind of cosmic sheet, floating in higher dimensional space. Other brains may exist, parallel to ours, each carrying its own universe, its own stars, its own time. Occasionally, these brains might even interact, their gravitational waves rippling faintly across the higher dimensional sea. If so, the birth of our universe, the Big Bang itself, could have been the result of two such brains colliding, their impact releasing energy and giving rise to the cosmos we now inhabit. It's a vision both scientific and poetic, the idea that our entire reality might be the shimmering resonance of strings and membranes vibrating softly in the stillness of higher space. Now let's pause for a moment and listen. If string theory is true, then the universe is not made of matter, but of music. The smallest, most fundamental entities are not particles or points, but tiny oscillating loops, vibrating at frequencies that define everything we see and feel. Each vibration pattern corresponds to a specific property: mass, charge, spin, the ingredients of the cosmos. Together, they create the intricate harmony we call reality. But the music of string theory is more than physical. It touches something ancient in us, the same sense of wonder that early humans felt when they looked up at the stars and imagined the heavens as a song. In many ways, the theory brings science and philosophy full circle. It suggests that unity exists, that beneath the apparent chaos of nature, there is coherence, structure, and beauty. It tells us that gravity, light, and the forces of nature are not separate notes, but chords in a single melody. And even though we cannot yet test it fully, even though the strings themselves are far too small to detect, string theory gives us a framework where the known and the mysterious can finally meet. It bridges the quantum and the cosmic, the invisible and the infinite, whispering that the same laws govern both atoms and galaxies. If that's true, then perhaps consciousness itself is another vibration, another subtle resonance within this cosmic song. You, as a being of awareness, are part of the universe's music, a note within the grand composition. When you breathe, when you dream, when you simply exist, you are vibrating with the cosmos, in harmony with everything that ever was, and everything that ever will be. So, tonight, as you rest, let yourself feel it, the quiet hum beneath reality, the gentle pulse of the universe, resonating through you. Every heartbeat, every breath, every thought is a chord in the universal song, the endless silent symphony of creation. And perhaps in that stillness, you'll sense it, the soft vibration of strings singing across unseen dimensions, forever weaving the story of existence. Everywhere we look in the universe, we find patterns of balance, of symmetry, a snowflake with its perfect repeating arms, a butterfly's wings, each side mirroring the other, the gentle rise and fall of waves, or the rhythmic pulse of a heartbeat. Nature loves symmetry. It's woven into everything, from galaxies spiraling in space to the smallest particles dancing in the quantum world. In physics, symmetry is more than beauty. It's a principle, a deep truth about how the universe works. It tells us that if you flip something, or rotate it, or move it in time, the laws of nature should remain the same. For example, whether an experiment happens in Paris or on Mars, today or tomorrow, its fundamental rules do not change. That's symmetry, a promise of consistency in the grand design of the cosmos. But sometimes, nature surprises us. When scientists began studying the behavior of subatomic particles, they found that symmetry was not always perfect. In the 1950s, experiments on particles called kaons revealed a strange secret. Nature, it seemed, had a subtle preference, a tiny imbalance between matter and antimatter. The mirror image of a process did not behave exactly the same as the process itself. It was as if, when you looked into a cosmic mirror, something was just slightly off. This discovery shook physics to its core, because if symmetry could be broken, then perhaps the universe we see, filled with matter, stars, and life, was a result of that very imperfection. For if matter and antimatter had been created in equal amounts after the Big Bang, they would have annihilated each other, leaving behind nothing but light. But something, some tiny asymmetry, allowed matter to win by a fraction, and that fraction became everything we know. So, in a way, we exist because the universe is not perfectly symmetrical, yet symmetry still calls to us, as though reality itself were reaching toward balance, seeking its reflection in some hidden form. This is where the idea of mirror universes begins, with the question, what if that reflection truly exists? What if, somewhere beyond our perception, there is another universe, a mirror world, where every particle, every atom, and perhaps even every person has a reverse twin, a world that looks like ours, but spins the other way. Imagine a universe made of mirror matter. Every particle in our world, the electron, the proton, the neutron, has a mirror counterpart, with identical mass, but opposite properties. If you could look at this world, it might appear exactly like ours, but everything would be subtly reversed, like a reflection in a cosmic lake. In our universe, the weak nuclear force prefers left-handed particles. In the mirror universe, it would favor right-handed ones. To us, that might sound small, but in physics, it changes everything. This idea, the mirror universe hypothesis, was proposed in the 1950s when scientists tried to make sense of why certain particles did not obey mirror symmetry. They wondered if perhaps the symmetry wasn't broken at all, but simply hidden. Maybe the universe does balance perfectly, but its other half exists in another sector of reality, one that doesn't interact with us directly. In this vision, our universe and the mirror universe coexist, occupying the same space, but interacting only through gravity. We wouldn't see the mirror world. Light from it wouldn't reach our eyes, and its matter would be invisible to our instruments. But gravity, that most patient and universal of forces, would still feel it. Some scientists have even suggested that the mysterious dark matter filling the cosmos could actually be mirror matter, an entire hidden universe, shadowing our own, silently shaping galaxies, yet forever unseen. It's a haunting thought that perhaps when we gaze at the night sky, we are also looking at the gravitational imprint of a reflected cosmos, a ghost world, moving in step with ours. Others imagine even deeper connections. What if every event that happens here is echoed there in reverse order? When you raise your right hand, your mirror self raises their left. When you look at the stars, they look back from the other side of reality. Of course, this is still speculation, a poetic merging of science and imagination, but it captures something profound about our human search for balance, the idea that nothing in the universe is ever alone. Every force has an opposite. Every action has its reaction. Every world, perhaps, has its reflection. And maybe, in the grandest sense, mirror universes are nature's way of completing the equation, of ensuring that even when symmetry seems broken, it is only hidden from view. Let's linger a little longer in the soft glow of this mystery. If mirror universes exist, what would they mean for the story of existence? Would time itself flow in the opposite direction there? Would entropy, the gradual drift from order to chaos, unfold backward as though their cosmos were rewinding while ours moves forward? Some physicists think it's possible. They propose that the Big Bang was not the beginning of everything, but a moment of perfect symmetry, from which two universes emerged, expanding in opposite directions in time. In one, ours, time flows forward. In the other, time flows backward, though to the beings within it, their forward would feel just as natural as ours. Two reflections, moving away from the same moment of creation. It's a breathtaking image, a cosmic mirror. That doesn't just reflect space, but time itself. And yet, these are not just fantasies. Mathematically, such mirror symmetries arise naturally in theories that seek to unify physics, including string theory, M-theory, and the study of quantum fields. Even in quantum mechanics, we find that particles can exist in superpositions, mirrored possibilities, until observed. Reality itself, it seems, is fond of reflection, And if we listen closely, we can sense the poetry of it. Perhaps consciousness, our awareness, is also mirrored in ways we don't yet understand. Maybe the choices we make here echo in another version of ourselves, in another world, with outcomes reversed like ripples in still water. Maybe that's why, when we dream, we sometimes find ourselves in strange, reverse places, familiar, yet not quite our own, perhaps dreams, our faint reflections of realities unseen. Of course, science has not proven this. Not yet, but the longing for symmetry, for completeness, is deeply human. We find comfort in balance, in the idea that the universe is whole and harmonious, even when its halves are hidden. Maybe that's why the thought of mirror universes feels so strangely calming. It tells us that nothing is lost, that everything has its counterpart. And so, as we float here, in our tiny corner of the cosmos, it's peaceful to imagine that somewhere in the quiet dark, our mirrored selves are also wondering, dreaming, searching for us. Two reflections, forever reaching toward balance, across the glass of infinity. The universe, for all our study and discovery, remained profoundly mysterious. Even after centuries of exploration, from the first stargazers tracing patterns in the sky, to the scientists today peering deep into the cosmic web, we have uncovered only a fraction of what truly is. And maybe that's the point, because there is something quietly beautiful about not knowing everything. The unknown gives depth to the known, the way shadow gives shape to light. Every question we answer reveals 10 more waiting beneath it, like stars hidden behind clouds, emerging one by one as our vision adjusts to the dark. In the world of science, the unknown is not an obstacle. It is an invitation, a whisper saying, "Come closer, look deeper, there is more to see." Think of how many great discoveries began as mysteries. Once, we believed the stars were fixed to a celestial dome. Then we learned they were suns, each with their own worlds, their own gravity, their own light. Once, we thought the earth was the center of everything. Now we know it is one world among billions, spinning quietly in a sea of galaxies. Once, we thought time was constant and space unchanging. Now we know they bend, twist, and dance together in a living fabric we call space-time. Every time we peel back one layer of reality, we find another waiting, grander, stranger, more intricate than we ever imagined. But no matter how deep we go, there is always a horizon, always a soft, unreachable edge. That edge is what gives a universe its poetry. Because if everything were known, if every secret were revealed, the wonder might fade. The beauty of existence lies in its vastness, its refusal to be fully understood. Even our minds, born from the universe itself, are not large enough to hold it all. And that's okay. The unknown is not emptiness. It's possibility. It's a field of infinite potential, stretching beyond the boundaries of our imagination, somewhere beyond what we can see. New laws of nature may be unfolding, new kinds of life may be forming, and new universes may be breathing their first light. And perhaps we will never see them. But that doesn't make them any less real, because in the quiet spaces between the stars, existence continues, mysterious, silent, and endlessly beautiful. There is a curious paradox. In being human, we are tiny, small enough to live and die, on a pale blue world, orbiting a single star, in a single arm of a single galaxy, and yet, within our minds, exists the capacity to imagine infinity. That's extraordinary. Somehow, out of dust and light, the universe has built creatures that can wonder about their own beginnings. We look up and ask, what's out there? We look inward and ask, who am I? And somewhere in between those two questions, science and spirituality meet, not as opposites, but as two sides of the same search for truth. Science gives us the tools to measure, to predict, to understand, but wonder, that quiet awe that fills us when we see the Milky Way stretch across the night, that comes from something deeper. It's the same feeling our ancestors must have felt gazing at the stars with no instruments, no equations, just eyes full of curiosity. That feeling is the heartbeat of discovery. Every explorer, every scientist, every dreamer is guided by it, even when equations fail and the telescopes reach their limits. It's wonder that keeps us going, the sense that there's still more to learn, still more to love, still more to see. When we study the universe, we're not just looking outward, we're looking back at ourselves, at the consciousness that allowed atoms to dream of the stars. We are the universe's way of asking itself questions. That thought alone is enough to fill a lifetime with meaning, because it reminds us that, though we are small, we are also infinite, made of the same elements as the stars, animated by the same laws that move galaxies and light. In the end, to be human is to live on the edge of knowledge, forever peering into the dark, forever reaching for a little more understanding. And in that reaching, we find purpose, not to conquer the unknown, but to stand in awe of it, to learn from it, to let it shape us, and to know that even mystery itself is a kind of truth. Now, as our journey draws to a close, let's rest here in the gentle quiet of reflection. Look up in your mind's eye and picture the night sky, the stars softly glowing, each one a sun, each one a story. Between them lies darkness, but even that darkness is not empty. It hums with energy, vibrates with potential, and carries the faint whispers of universes yet unborn. We often think of the unknown as something far away, beyond the stars, beyond time, but it's also within us. Every thought, every dream, every heartbeat is part of the same mystery. When you close your eyes, the same cosmos that stretches for billions of light years continues inside you in the electric symphony of your neurons, in the atoms that once burned, in the hearts of ancient stars. You are not separate from the universe. You are the universe for a brief moment, becoming aware of itself. And maybe that's the greatest discovery of all, not the theory or the data or the answer, but the realization that we are woven into the mystery itself. So perhaps we don't need to solve the unknown. We simply need to listen to it, to rest in its presence, and let its silence teach us. Because the unknown is not empty. It's sacred space. It's where wonder lives, where potential becomes creation, where the universe breathes. And in the stillness of that breath, we can hear something timeless, a soft echo, as if the cosmos itself were whispering, "You are part of me. You always have been. You always will be." So tonight, as the stars drift silently overhead, let yourself feel that connection. Let the mystery wrap around you like a gentle blanket of infinity, and know deeply that the unknown is not something to fear. It is something to love, because it is in the unknown that dreams are born, that questions awaken, and that wonder, the most human of all emotions, continues to glow. And with that thought, we reach the end of our journey. The lights of knowledge have guided us, but it is the darkness of the unknown that gives a meaning. So sleep peacefully, curious traveler. May your dreams drift through galaxies. May your thoughts rest among the stars. And may your heart remain open to the endless beauty of the universe's quiet mystery. Good night and goodbye.